Let's take a look at the first periodic waveform. This is nothing else, just sine wave. We're supposed to find period of this sine wave. Remember that the period is the time required to finish one full cycle. One full cycle is this part of the wave, which is always repeat. So how many cycles I have? One, and I have another cycle over here. The period of one full cycle is 20. This is my period. 20 milliseconds. So period T is equal 20 milliseconds. Remember, period is the time required to finish one full cycle. Next, we have to find number of cycles. How many cycles we have? This is one full cycle, and this is the second cycle. So I have 2 cycles. Number of cycles is equal 2. I want to find the frequency of this wave. Remember, the formula for frequency says frequency is equal 1 over period. 1 is my constant, and T is my period, 20 millisecond. 1 divided by 20 millisecond is equal 50 Hertz. Next, we're supposed to find the positive amplitude. Positive amplitude is the maximum value of my wave. In this case, this is voltage, that's why this is going to be maximum voltage, and this is going to be equal 3 volts. Maximum voltage is also called voltage peak. I'm going to use voltage peak always. So I have voltage peak equals 3 volts. This is my maximum voltage. This is my amplitude, positive amplitude. Negative amplitude is my negative maximum voltage. So I have negative voltage peak is equal minus 3 volts. Minus 3 volts is my negative voltage peak. Voltage peak to peak is the voltage from the top to the bottom. This is nothing else, just the difference between these two voltages. Voltage peak to peak is equal positive voltage peak minus negative voltage peak, which is going to give me negative times negative gives me positive. So I have voltage peak plus voltage peak is equal 2 times voltage peak. So my voltage peak to peak is equal 2 times my voltage peak, which is equal 3 volts, is equal 6 volts. These are the solutions to the problem.